Hi everyone, my name is Jonathan Robles, and today I'm going to explain you my poster. This work is focusing coumarin derivatives as potential corrosion inhibitors for C844 bronze in a saline medium. This is a theoretical and experimental study. Well, for the abstract, in general, this study is focusing coumarin derivatives because are organic compounds. And well, we obtain that the best concentration for the organic compounds that we study is 5 ppms, and the inhibition efficiency achieved was 63.1% for the 3-acetyl 7-hydroxycoumarin. And well, this study was complemented with a theoretical study using DFT and Coumarin technique to know how are the bonds between the copper atoms and the oxygen and hydrogen atoms. Okay, well, for the introduction, this study was focusing copper because exist some historical and cultural sculptors in Mexico and in other countries, and for that reason, we focus in study the inhibition of copper because, well, we want to have a better preservation of these sculptures. Okay, and well, was study the coumarin derivatives because are organic compounds, and for that reason was chosen. The methodology that we follow was for the computational method was the functional M062X, and the basis set was land L2DC. This was the computational method that we use. In this case, we use the Measley equipment for do these theoretical calculations. And well, in the case of the experimental test, was we used well, a circular bronze plate of 11.94 centimeters square. Well, this was the working electrode. For the counter electrode, we use a graphite electrode, and a silver chloride electron was used for the reference. Okay, was used a 3% saline solution for the experiment. And well, in this case, we obtained the open circuit potential test. We obtained the electrochemical impedance spectroscopy in this range, and well, we obtained two depolarization curves. Okay, and now the results and the discussion. Well, the experimental results that we could see are this. For the figure 2, we can see the Nyquist diagram that is necessary to obtain the inhibition efficiency. As we can see, the higher diameter of the circumference was for 5 ppm. This was obtained for the 3 compounds, so the best concentration to obtain inhibition efficiency is 5 ppm for all the organic compounds. In this figure, in the figure 3, we can see the Langmuir isotherm for the coumarin derivatives, and well, we obtain this to do the thermodynamical analysis. Okay, in the case of the theoretical study, we can see in the figure 4 the optimized structure for the 3-acetyl coumarin with a copper 7 cluster. We use a copper 7 cluster to be the model of the copper as copper surface. And well, with the method that I explained before, this functional M062X and the basis set that I mentioned before, we choose this because it was the best computational method. We tried different computational methods, and this was the best. In the figure 5, we can see a molecular graph that we obtained for do the Q-time analysis. We could see that in these orange points, we have that the interactions and the chemical bond between oxygen and copper are ionic bonds, and between the hydrogen and the copper are weak bonds, considering the values of the electron density and the Laplacian of the electron density. Okay, in figure 6, we can see the electrostatic potential map that we obtained for the 3-acetyl coumarin interacting with copper 7 cluster. And we can see that, well, the most negative region is around this oxygen atom in the functional group. And we obtain the HOMO and LUMO orbitals, and we can see in the figure 7, that is this figure, that, well, the HOMO and LUMO orbitals for the interaction between organic compound and the copper cluster. As we can see in the HOMO beta orbitals, exists an interaction between the oxygen atoms and the copper atoms that we corroborate with the molecular graph in the figure 5. Okay, well, to obtain the mathematical model, we use the figure 8, that is the equivalent electric circuit, to obtain the Nyquist diagram, the curve that fits the concentrate, well, the curves, this curve that fits them, the curves of the circumference. Okay, and well, finally, we have 3 different tables. The table 1 shows us the electronic parameters that we calculate for the different organic compounds and the copper cluster. We can see here the energy of HOMO orbital and LUMO orbital, and we can see here the another parameters, for example, the electronegativity, the electrophilicity, the electron donating ability to know how is the charge transfer process, and we can see here the hardness, and well, the electronic parameters that we obtain for the systems that we study. In this case, we study these 3 systems. Okay, in table 2, we can see the charge analysis. We make a charge analysis to know how is the MBO charge after the copper interaction and how is the Bader charge analysis after the copper interaction, to know how is going to be the charge transfer process between the copper and the organic compound. And well, we can see here how is going to be the interaction in this case. Okay, for the Bader charge, fix with, well, we use Bader charge to fix the results obtained in the MBO charge, and we can see that this well, the Bader charge is correspond with the electron donating ability obtained for copper, and the results are how we want to be. Okay, in the table 3, we can see the experimental results and the inhibition efficiency that we obtain. In the 3 cases, the highest value is for the 5 ppm concentration. Okay, and the highest of all the results are the 5 ppm concentration for the second compound, the second organic compound. Okay, and well, finally, for the conclusions, we obtain that the best organic compound is the, how I mentioned before, the 3-acetyl 7-hydroxycoumarin at 5 ppm, because we obtain the highest value of inhibition efficiency, in this case 63.1. Okay, and well, with the theoretical analysis, we corroborate that exists an interaction between the oxygen atoms and the copper atoms of the cluster. In this case, we can corroborate this with the orbitals and with the molecular graph that we have in the figure 5. Okay, and well, here are the reference, and I thank you so much for your attention.